Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7, want to present our mechanism to transport FFB to collect the center. And the title for this project is Tilt Belt Equipment Trailer. So I would like to introduce my team member, which is Muhammad UZAIR bin Muhammad SHUKRI, with matric number of 202457 as a project manager, and SHUDHARSON ILENGO 202460. As a senior engineer, and Muhammad UWAIS AQIL bin AZARY 202459 as a senior engineer, also me as a senior engineer, which is NABIHAH binti ROSIDI with matric number of 202458. Okay, next. Okay, so I will continue with the introduction. First, this project is to identify the problem faced by the transportation sector of Malaysian oil palm industry nowadays, and it comes with its respective solution to improve the efficiency and productivity of the oil palm industry in Malaysia. So we have three, we divide it into three, which is problem statement, purpose solution, purpose target market. Okay, for the problem statement, it is to the uneven terrain will result in protracted mobility of trailer, and the bad soil condition have made traveling of trailer is difficult and dangerous, and the condition of the weather also made the transportation of FFB by trailer become troublesome to carry out, and it reduce the efficiency of the overall pump process, and moreover it increase the cost of industry, and the wastage of the oil palm resources due to the loose fruits from the oil palm, and collection of loose fruit is relatively difficult and time consuming. And we propose a solution which is designed that optimize the route of transportation process in palm oil FFB to represent a capacitated shortest route problem, and the fresh fruit bunch and loose fruit will need to be efficiently carried by the vehicles, and the vehicles will need to get rid of the main problem, which is as we said that before, the vehicles need to drive on the terrain, since it is large and which cause the slow movement, and it must be designed with less maintenance due to the weather condition and that keep raining. And we target this product for the medium plantation owners, which is 40 that has 40% of palm oil plantation and owned by the small farmer. And this product will constructed to be compact and robust with the most efficient weight distribution ratio to ensure it can have a superior flotation and excellent maneuver capability in hilly terrain and swampy areas. Next. Okay, so basically this is our conceptual designs. Design A, B, and design A, B, C, and D are referred to the design reference. All these design actually have advantages and disadvantages that discuss more detail in the report. Next. Okay, so based on that design, we do the concept screening, where the results is the most highest from between design A, B, C, D is design A and design B. So we would like to do the concept scoring between this design. Next. We also made some improvement before we proceed to the design scoring, concept scoring. And so we get design A plus and design B. And the improvement made from design A is that the mini tractor was changed into trailer, so it can be connected to any suitable attachable vehicles. And the location of the suction pump hose also changed to the upper part of compartment to reduce any, since we want to reduce any possible pressure when it is operated when the compartment is filled with FFB. And the hose of the suction pump is also bendable, and it can be installed or removed when needed. And there are also two parts of features that remove from design A. Basically, we remove the sweeper and the bucket for loose SSB, since we replace it with the hydraulic system that will ease the process of unloading all the FFB in the compartment. Next, I will pass to my other team members.
Okay, thank you, Dini. So for our project, so we have 6 main part, which consists of chassis, compartment, hydraulic cylinder, suction pump, tire, and also the connector. And also this is our final design. Okay, next. So for material and type selection, for chassis, we choose the material AISI 4140 because it's lightweight and also lightweight but have high durability. Second part is the compartment, which the material is used is the ultra high molecular weight polyethylene UHMWPE because it has high wear resistance, toughness, biocompatibility, and also durability. And so for the part tire, we use the radial tire type because it has good traction and also good soil compaction. And for the hydraulic cylinder, we use the welded cylinder because it has good durability and also performance. The last part is the suction pump. We use the centrifugal pump because it has a smooth flow to pick up the loose FFB. Okay, next for engineering analysis. So after we calculate the load and also others, we found that the action and rear tire at the rear wheel is 9603.12 Newton. For the front wheel is the 5541.30 Newton. And then for the hydraulic cylinder, we find that the shear stress on the pin is 3.513 megapascal. And last one is for the suction pump. The suction pump need to have the minimum of 2.166 horsepower in order for us to pick up the loose FFB from the ground. Okay, next I will pass to UWAIS.
Okay, thank you, Zaid. For the NC simulation, there is a two part of simulation which we are doing. First is total deformation and second is the balance stress. For total deformation, the max total deformation obtained is 0.112 mm and the average total deformation is 0.036 mm. And then for the equivalent stress, the maximum is the 20.44 MPa and the average equivalent stress is 0.667 MPa. Okay, next. Next is the connector of the hydraulic cylinder between the compartment, which is the same as before, which is we do the analysis of the total deformation and equivalent stress. The minimum for the total deformation is 0 mm and the average is 0.01 mm and the maximum obtained is 0.02 mm. And then for the equivalent stress, the minimum obtained was the 0.12 MPa and for the average obtained is 7.9 MPa and the maximum obtained is 33.6 MPa. Okay, next. Next, I will explain about the limit and tolerance. Some of part has been taken, which is the back chassis compartment connector, compartment door, hydraulic cylinder connector, and hose and compartment. The type of fit is for the first part is serif fits, and second is also serif fit, and third and fourth it is same, which is locational fit. And for the nominal dimension obtained for the first is the was set is 8 mm and then 10 and then 40 and then 75. And there is the limit and tolerance based on the data table. Okay, next. For the safety factor, there is a three part, which is chassis, compartment, and connector attachment. The material for chassis is AISI 4140 with a minimum safety factor which is 0.63, and for the compartment the material used is UHMW PE, which is the minimum safety factor is 0.57, and for the last is connector attachment, which is we use 304 stainless steel, which is the minimum factor. The minimum factor is 0.41. This all of me. I will proceed to Sudha.
Hello everyone, very good evening. Okay, so for the cost analysis, we have tabulated some data. So firstly, let's get into the price of material. So the price of material costs around 9,848. For the machine quantity and cost for production for a trailer, it costs 9,884, which includes the machineries such as MIG welding machine, grinding machine, and powder coating machine, etc. So for the employees and salary, we have managers, supervisors, skilled workers, and also laborers. So it costs around 40,000. For the overhead costs, we have fixed costs and variable costs. So the fixed cost, which includes insurance, rental, about 48,000. For the variable costs, such as the goods and equipments and the usage of resources, we have 15,850. So for our calculation, we have calculated the profit to be earned. So the total cost for machinery, resources used, and labor per unit is 111.70 cents. So manufacturing cost for one unit trailer, it costs around 9,848. So total cost for one trailer production, we should add for the machinery and also the price of one unit of trailer. So which it costs around 9,960. So for this, we plan to fix a selling price, which approximately costs double of our production cost. So we decided to fix it at 20,000. So the total gross, we plan to sell 500 units. So we will gross about 10 million. And for the manufacturing cost, it will cost 4,098,090. So a profit margin per unit that we can obtain by selling our product is around 10,039 ringgit. Next. So to get even clearer image, so we did break-even analysis. So to get the break-even point, to get the model that we have invested by selling our product, we got 12 units. We did it using Excel. So whereby we can use this formula, total fixed cost over price per unit minus the variable cost. We got 12 units. So we will have to sell 12 units to get back our model. Next. So the conclusion, the final design of the mechanism that transport FFB to the collection center has met all the necessary requirements. Our product, which is the tilt bed trailer, was chosen as a solution to efficiently move the FFB to the collection center. It really saves time, and we are confident that it will be a cost-effective solution. The design met all the technical requirements and design criteria, including the dimension and specification for all parts of the tilt bed equipment trailer. So we hope that we have presented well. Thank you. That's all from us.
Thank you.